Good morning. Welcome from Germany. My name is Hans-bernd Kittlaus. I'm very happy to be able to talk to you this morning at Product Camp Pittsburgh. Unfortunately, I cannot do this live, so this is a pre-recorded presentation, but I hope in case you have questions, you can send me questions per email and I will give you all my contact information later on. In this talk, I want to look at the increasing diversity that we see in product planning approaches and also on the development side over the last 10 years. So let me share my screen with you. Before I start, a few words about myself. My name is Hans-bernd Kittlaus. I run my own training and consulting company called InnoTivum, and I'm also the chairman of the International Software Product Management Association, in short, ISPMA. I'll give you some more information on ISPMA in a minute. My background, I've spent all my career in software, starting with studying computer science in Germany. Then I worked for IBM for quite a long time as a software developer, and then in project management, line management positions. And that is also where I had the first opportunity to work as a product manager. So I was responsible for one of IBM's operating systems, and later on for IBM's database and application development products. Then I left IBM and joined a customer organization, and that was the German Savings Banks organization. That is the largest retail banking organization in Germany with a market share of more than 50%. When you travel through Germany, you see this red S, which is the logo of the organization everywhere. And in that organization, I became the director of their computer science center. And we also introduced software product management in that banking organization in their IT centers. Then I started my own company, InnoTivum, and since then I've done lots of training and consulting projects for all kinds of software organizations, some huge corporations like Infosys in India, Samsung in Korea, IBM, some mid-sized companies, some startups, in different industries. So some of them in the software industry, some in manufacturing, automotive, banking. So pretty huge spectrum. I published a number of books on software product management. The latest one is what you see here on the left side. That was written with my co-author Samuel Fricker, who is also an ISPMA board member. And this book can be used as a textbook because it is compliant with the ISPMA body of knowledge on software product management. So it can be used as a textbook for any courses and trainings based on ISPMA material. ISPMA was started about 11 years ago, and the start came from a group of experts from both the industry and academia with the objective to establish software product management as a discipline of its own, both on the industry side and on the academic side. You are certainly aware that so far there has been very little specific academic education on software product management. So that is something that we work on, and it is changing. So we are very happy that at Carnegie Mellon University you have this master study program on product management, and actually Greg Kutichia is one of our fellow members. You see him here on the slide. And we also see academic institutions in other parts of the world who offer courses and master programs on the subject, both in Europe and in Asia. So there is some progress. And when you look at this slide here, these are our so-called fellow members. So these are the experts that really work on the contents of ISPMA's body of knowledge on software product management. And this is a very diverse group of people from all over the world, some of them university professors, some practitioners from the industry. You see here at the bottom, this is Michael Cusumano, who is a professor at MIT, and he is considered as the founder of academic research on the software business, has published tons of books on this, and we are very happy to have him among our fellow members. So very nice group of people, and that is really unique about ISPMA, that all these experts contribute to our body of knowledge and our syllabi. ISPMA has developed what we call the SPM framework. So this is an attempt to show on one page all the relevant areas of a software organization from a product manager's perspective. So you see here on the right side the functional areas of development, marketing, sales, and services, which a product manager needs to orchestrate so that all these units contribute to the success of the product in the best possible way. Here you see the columns product strategy and product planning. This is the core responsibility of a product manager. And on the left side, we have strategic management. These are activities on a corporate or business unit level that product managers participate in. The structure of this framework is also the structure of our body of knowledge and of our training modules. And in these columns, you see the most relevant activities that need to be performed either by the product manager or by the other functional areas. This does not mean that we want to set a standard how you organize a software organization. So that's why we talk about functional areas here. How you translate that into an organizational structure can be very different from organization to organization. The structure of ISPMA's curriculum, we have a module called Foundation Level, and then we have modules on the excellence level that look in more detail into the different areas of product management. Each of these modules comes with a syllabus, and you can download all these syllabi from ISPMA's website for free. And each module comes with its own certification, so based on a certification exam. That's the current structure. We are continuously working on updates, so we want these modules to be up to date and reflect what is going on in the industry and in practice. And we also work on adding modules to this curriculum. One that we currently work on is a module on product management for startups. And my colleague Haragopal Mangipudi is going to talk about that in a session in the next time slot. ISPMA has also established a conference called Software Product Management Summit. We have just had the latest European conference in Frankfurt a few days ago. Very nice conference over 2 days. We did this as a hybrid conference. So yes, there was a physical conference in Frankfurt, and we also offered an online version of this. We plan more conferences in 2021 if the corona crisis allows. So one is planned for Bangalore in India in cooperation with the Indian Institute of Management in Bangalore, which is the #1 B school in India. We have already done 2 conferences there, so this will be the 3rd one. And we also plan a conference in Pittsburgh for next year in cooperation with Greg Koticha and Carnegie Mellon University. So we are very excited about that, and let's hope that we can do it next year. And then all of you are certainly invited to join us for this conference. In this talk, I want to look at the increasing diversity in software product planning approaches. And we'll look at these different approaches, how they map to different software product scenarios. And then we'll go in a bit more detail into requirements engineering and release planning. Well, when we look at what is happening in practice, for a long time, the dominant approach in software was and maybe still is requirements driven. So we looked at requirements from all kinds of sources. We analyzed those requirements. We made decisions which requirements we want to implement in the product, and then we implement them. So that was the dominant approach for a long time. And this is an area where you find lots of publications, books and articles on requirements engineering. The academic community has worked on requirements engineering intensively for the last 30 years. Lots of books, conferences. So there's a lot of knowledge on requirements engineering. And so you can say that this is the area that has probably the most publications of all the topics that are relevant in software product management. A lot of these publications are on requirements engineering in a project environment, but most of that can be transferred to a product environment. Over the last 10 years, we have seen new approaches, and these new approaches have gained quite some popularity. One is called data analysis driven. So this means that you try to collect data from how users work with your product, and that drives decisions about the selection of requirements and how to implement them. And then we have a third approach, which we call data input driven. This is primarily from the artificial intelligence area, machine learning, where the software needs to be taught based on input data. So these two approaches are clearly different from the traditional requirements-driven approach. But the requirements-driven approach continues to be relevant, in particular in areas like legal or regulatory requirements, in the area of commodity functionality and commodity products, in requirements that are technology-driven. Also, when we talk about back-end functionality, that is usually still pretty much requirements driven. And this works well in environments that are vendor controlled, but you also find it in customer controlled environments. And we will talk about that in a minute, how we differentiate these environments. The data analysis driven approach, that basically means that we design and execute experiments under uncertainty, and then we analyze the data that results from these experiments. So this is about optimization under uncertainty, very applicable to really innovative things that we want to implement in our products, and even more applicable when we talk about front-end functionality and design. This works very nicely in vendor-controlled environments where you as the vendor have direct access to data in that runtime environment. That is a bit more difficult when the runtime environment is under the control of your customers. And then the third approach, data input driven, so primarily relevant in the machine learning domain. So this means that data sets are used as input to the engine for the learning process. There are frequently used techniques in these different areas. So when we talk about requirements-driven approach for software products, market elicitation is a fundamental technique. Requirements need to be analyzed in depth and then selected. For the selection step, there are also established techniques. So this is a pretty well-known approach. When we talk about the data analysis driven approach, that's where we look at techniques like minimum viable product, experiment design and implementation, like I'm sure you are familiar with A/B testing, or approaches like customer discovery, and we need to apply statistics in this space in order to analyze the data. And then for the data input driven approach, you need to design the relevant data structures, you need to collect the data, you need to cleanse the data before it can be input to the machine learning engine. So these are typical techniques that we look at in the different approaches. This structure of these three different approaches is based on a publication by our fellow member Jan Bosch, who is a professor at Chalmers University in Sweden. He published this under the title Holistic DevOps Framework, and you can find his publication on LinkedIn. I already talked a little bit about these different scenarios. So we differentiate scenarios where the vendor of the software is in control of the runtime environment versus a scenario where the customer is in control of the runtime environment. So the latter one is typical for software license products that the vendor sells and the customer installs and runs in his operating environment, in his computing center. Vendor-controlled environments, so that is typical for internet platforms or for software as a service offerings where the vendor is also responsible for the hosting of the software. The second criterion that we look at is where is the product in its life cycle. So we differentiate new product development, what we call revolution, from existing product evolution. And when we apply these two criteria here, we end up with 4 scenarios, and we have used ship names, boat names for these scenarios to indicate that the speed at which you deal with requirements and their implementation is different in these different scenarios. So the vendor-controlled environment for new product development, that's what we call powerboat. If it's existing product evolution, we call it speedboat. And in customer-controlled environments, we call new product development icebreaker, and existing product evolution cruise ship. So we will come back to these scenarios a couple of times in this presentation. Now let's look at where we focus on in the SBM framework. And we talk about product planning approaches, so that's this column, product planning. And first we look at product requirements engineering. So when we are in a speedboat scenario, you remember that's a vendor-controlled environment, and the product is already in the market. You already have customers, and now you work on the evolution of the existing product. So that's where you can apply experimentation, and you want to monitor and analyze product usage on an ongoing basis. And this is where techniques like product discovery can be applied. So product discovery basically means we monitor the usage of new functionality, and depending on how users make use of this new functionality, we decide whether we keep it or change it, extend it, or we discard it. Maybe nobody wants it. As we all know, there are statistics for software products that say that more than 50% of changes in the product, new functionality in the product, is not used at all by the customers. So product discovery helps you to make that number considerably lower and really focus on functionality that users want and use. A/B testing. So that's an approach where you implement certain functionality in two different ways, and then you give one implementation to one customer set and the other implementation to the other customer set, and you monitor how these customer sets use the new functionality. And based on the data, you then decide which implementation you want to keep, which one you want to throw away, and maybe you also get indications what to change or extend. So these are very popular techniques that are used in this speedboat scenario. Another one is a freemium pricing model. You may know that from the online gaming companies. So this is used to make the hurdle for new users as low as possible, so that you get a high number of users and thereby faster feedback for anything you do in that product. Now let's look at experiment design and implementation. So when we talk about design, first of all, we need to think about the hypothesis that we want to verify or falsify. When we have defined this, then we can decide which key indicators we want to measure for this verification or falsification. We also need to look at the statistical side. So what are our statistical requirements? For example, with regard to the sample size, those kind of things. And then the question is, how can we implement the experiment? So is our software and infrastructure prepared for these measurements? And can we get access to the measured data? So once you have answered all these questions, then you can implement the experiment. So first of all, you need to prepare the software, the infrastructure, and the data access. Then you execute the experiment, and then you analyze the resulting data. Now, let's look at A/B testing as an example for this approach, for these steps. With A/B testing, we have two different implementations, A and B, and our hypothesis is that our new implementation B improves our conversion rate by 20% compared to the current implementation A. So this already indicates that our key indicator is the conversion rate. So that's the measurement. Now we need to calculate what is our minimum sample size for the two alternatives, so that our result is statistically valid. And then we need to make sure that we can measure this and we get access to the data. In general, it is a challenge to find a key indicator, a measure that is sufficiently aligned with the hypothesis. So in our example, that's fairly easy. That's the conversion rate. But in other types of experiments, this can be more difficult. So let's assume you want to measure the productivity of users. Well, at first sight, the average time to finish a task looks like a wonderful key indicator. But when you think about it, this can be dangerous, because it does not take the quality of the result into account. So that's what you need to think through, which key indicator, or maybe multiple key indicators, really are able to be used as the basis for a decision on the hypothesis. The next challenge is the statistical size. So what is the minimum sample size that we need? So in this example, we talked about a conversion rate of 2%. We want to be quite sure that what we come up with is likely. So we set the statistical significance to 95%. And now we can calculate what is the minimum sample size, and the algorithms tell us we need 20,000 cases. There are tools that help you with this kind of calculation, like Amplitude or Optimizely or VWO. So you can use these kind of tools, and they have implemented this kind of calculation. So this is a pretty high number in some situations. In other situations, this may be very okay. Think of Amazon. I mean, 20,000 customer visits is not a big sample size for them. But for other internet platforms, in particular, when you focus on a particular functionality on the platform, 20,000 can be a really big number, which means that you have to run the experiment for weeks before you get to that sample size. Well, we can measure, in this example, the conversion rate for both A and B by presenting A and B to arbitrary customer sets, but that assignment needs to be fixed. So one customer always has to see either A or B. And then we stop the experiment when the minimum sample size that we calculated has been reached. And then we can calculate the average, the conversion rate for both A and B and compare that. Of course, this has a number of prereqs. So in your runtime environment, you need to be able to present A and B to different customer sets. So that requires some tool support, and it also requires an architecture of your software that allows this kind of differentiation by customer sets. So in order to set this up, it really requires significant preparation work. So that's something you need to take into account, in particular when you start with these kind of experiments. Data access, well, when we are in powerboat and speedboat scenarios where your organization is in charge of the runtime environment, then it's usually not a big problem to get access to the measured data. Of course, you need to take privacy regulations into account, but usually it's easy to get the data. And then the question is, what do you want to do with all that data? I mean, we all know there are players in the market like Amazon or Google, and they store everything that happens on their platforms, and they keep that data for forever, basically. The question is that what you want to do? It's an investment, and the question is, will that data ever be valuable? Will you ever need that data to answer questions? So that's a decision you have to make when you use this kind of approach. In icebreaker and cruise ship scenarios, it is more difficult because the customer is in charge of the runtime environment. And typically, in particular, B2B customers are not willing to give you access to data in their systems. That may change. So the more B2B customers move to agile approaches internally, the more they may be open to this kind of cooperation. And if the customer is open for it, this may even be an opportunity for a professional service offering where you cooperate with the customer to set up these kind of experiments in his environment and run these experiments and analyze the resulting data. Well, once you have set everything up and you start your experiment, then the question is, how long do we let it run? And I already talked about different situations. So if you do A/B testing in parts of the code that are not heavily used, it can take forever till you reach the minimum sample size. So very often in reality, these experiments are stopped earlier when you have not yet reached the minimum sample size. And then from a statistical point of view, the results are not sound. So that is one of the problems with these approaches. Um, on the other hand, when you do this in parts of the code that are heavily used, you may reach your minimum sample size very quickly. And typically, then you stop the experiment. But that can also be a problem because it may mean that you do not take longer business cycles into account. Think of an e-commerce platform. Uh, you have reached your minimum sample size within an hour and you stop the experiment. But you have not even looked at a full business day and the way users use your platform may change over a full business day. That's not included in your experiment. So these are questions that you also need to take into account. All right, now that was some considerations on requirements engineering. Now let's look at release planning. The term release is used in different definitions. So when we talk about releases from a product management perspective, we really mean market releases. So when we talk about licensed products in icebreaker and cruise ship scenarios, then a release is an instance of the product that is delivered to customers and is maintained as part of product maintenance. In software as a service environments, powerboat and speedboat scenarios, a release is an instance of the product that is available to customers at a certain point in time. And in these scenarios, the vendor may change the product in its runtime environment much more frequently than you would do with licensed products. Amazon claims that they do 1,000 releases per day. So that is really a totally different situation, and their release only means that you deploy a small change in your runtime environment. And then we also have the term release in agile situations, and there it is usually used more in the sense of a development release. So it is a result of a development activity that is testable. So for example, the result of a sprint in Scrum. Now, when we look at our fast scenarios, powerboat and speedboat, they can have a pretty high release frequency, but the releases are small, often small changes. That's where you can apply special techniques. Release planning is usually only done for bigger requirements and for requirements that have dependencies between each other, but not for all these small changes. In the icebreaker and cruise ship scenarios, think of licensed products, the release frequency is much lower, but the releases are bigger, more changed and new functionality. That requires more planning. So here you typically do strict release planning for all requirements. And there are all kinds of techniques that can be applied, like minimum viable product. Don't want to go through all the details. I assume you are familiar with that. You can apply product discovery and A/B testing. We already talked about that. This is where you find DevOps as an organizational approach for the tight cooperation between development and operations. And this also requires a certain architecture of your software that supports these small changes in the runtime environment without having to take the system down every time you want to apply such a change. So this can be a very powerful scenario, but there are a lot of prereqs that you need to install. The advantages of these scenarios and the techniques in these scenarios from a product manager's perspective are faster time to market, faster cycle time based on learning. So for example, when you introduce a defect in your system, you can fix it very quickly. And bottom line, you increase productivity. But there are also some challenges. So when you use DevOps, that means requirement-related decisions are more decentral. So you need to make sure that they continue to be synchronized with your product strategy and your priorities. It can be more difficult to get market attention for new releases of your software when you are in this continuous deployment mode. And also these continuous changes may not always be considered as positive from the perspective of an individual customer, because it means that things change and the customer has to adjust to these changes whenever they are deployed. So with that, let me summarize the talk. We looked at these three different approaches for product planning. There is increasing diversity, so no longer only requirements driven, but also data analysis driven and data input driven. As a product manager, we need to be prepared to apply all three approaches depending on in which scenario we are, what is the type of product we are looking at, the type of functionality we want to implement in the product, and there is also a dependency on the technology and the architecture of our product. With that, I would like to close this session. Thank you very much for your attention. I'm sure there are questions, so please feel free to contact me. You see my contact data here on this slide. I also make this slide deck available to you, so feel free to send an email and I'm happy to answer your questions. Now enjoy the rest of this product camp, and I hope I can see you in Pittsburgh for the SPM Summit next year. Thank you very much.